average power associated with capacitor. My dear student, now we can also prove that just like the inductor in which magnetization and demagnetization takes place, in case of capacitor the charging and discharging takes place. So average power associated with the capacitor is also zero. So in case of capacitor, we know that the current is leading the voltage. So accordingly, the equation of EMF, if EMF is E is equal to E naught sine of omega t, then what should be the current? Current should be I is equal to I naught sine of omega t plus pi by 2, since it is leading the voltage. So now the power associated is given by E into I, which is equal to E naught I naught, this is equal to I naught cos of omega t, right? So this is sine of omega t into cos of omega t, multiply and divide by 2, this will become sine of 2 omega t. So this is E naught I naught by 2, this is sine of 2 omega t. Now the work done can be calculated by integrating this. This is E naught I naught by 2 integration 0 to t, this is sine 2 omega t. We have already proved that integration of sine 2 omega t is equal to 0 in our previous video. So accordingly the work done is 0, or we can say that average power associated with capacitor is 0, right? Now we can show with the help of the alternating waves diagram that how does the charging and discharging of capacitor takes place. Okay, now let us understand with the help of this diagram how charging and discharging takes place. Now we know that the current is leading the EMF by pi by 2. So we have drawn here the diagram. You can see that EMF is starting from mean position, so I is starting from maximum position. Just like in the previous case I have explained, in case of circular motion, now I is at mean position and EMF is I is at maximum position and EMF is at mean position. So here you can see that current I is leading EMF by pi by 2. So the graph is just like. Now from the time 0 to t by 4, you can see that current is increasing. This current is positive and EMF is also positive. So in that case product power is positive and we can say that the capacitor is being charged. In that case we can say that E and I are positive, so power is positive, and we can say that energy is taken from the source. Energy is taken from the source. Now from t by 4 to 2t by 4, you can see here in this portion EMF E is still positive but decreasing, but current is negative, that is it is increasing in opposite order, right? So in that case the product E and I is negative, so power is negative, and we can say that now the energy is given to the source, means the capacitor is being discharged. So energy is given to source, energy is given to source. Next, from 2t by 4 to 3t by 4, you can see that both E and voltage, current and voltage, both are negative. So product is positive, so power is positive. Now in this case the capacitor is being charged in reverse direction. Suppose in first case the first plate was positive, now in that case the first plate is having negative charge. So charging is in opposite order. So again, since power is positive, so energy is taken from the source. Again from 3t by 4 to t, you can see here both current, here you can see the current is positive but EMF is negative. So the product is negative, and it means that now capacitor is being discharged in the negative direction, and we can say that energy is given to the source. So this is how the charging and discharging of a capacitor being done. when we can have the knowledge of average power associated with the capacitor.